In the vast silence of space, there are places where light itself is swallowed whole. These are black holes, the most mysterious and powerful objects known to science. Invisible, relentless, eternal. They sit quietly at the hearts of galaxies, shaping the universe in ways we're only beginning to understand. But every now and then, even the quietest black hole reveals its presence, when it awakens to feed. For decades, scientists believed that most black holes simply sat idle, doing nothing unless a star or cloud of gas came too close. But new discoveries are painting a very different picture, one far more dramatic and energetic than we ever imagined. Recently, a group of astronomers using data from NASA, the European Space Agency, and several powerful ground-based telescopes, have observed something extraordinary: 3 supermassive black holes caught in the act of devouring entire stars. Each one releasing more energy than 100 exploding suns. Each one lighting up its galaxy like a cosmic beacon. These are called extreme nuclear transients, the most powerful explosions seen since the Big Bang itself. The hidden power of black holes. To understand these events, we need to remember what a black hole really is. A black hole isn't a thing in the normal sense. It's a region of space where gravity has become so intense that nothing, not even light, can escape. Around it lies the event horizon, a boundary beyond which everything is lost forever. Most galaxies, including our own Milky Way, have a supermassive black hole at their centers. Some are quiet and dark. Others are constantly feeding, consuming gas, dust, or even entire stars, creating bright, glowing disks of hot material that we can see from billions of light years away. These bright black holes are known as active galactic nuclei, and they can outshine all the stars in their galaxies combined. But most black holes are quiet, sleeping giants that wait silently for the next unlucky star to come too close. A star's final moments: when a star drifts near a supermassive black hole, gravity stretches it like taffy. The side of the star closer to the black hole feels a much stronger gravitational pull than the far side. This difference tears the star apart in a violent process called a tidal disruption event. Half of the star's material is thrown into space. The rest spirals inward, forming a glowing disk around the black hole. As this matter falls in, it heats up to millions of degrees, shining brightly in X-rays, ultraviolet light, and visible wavelengths. It's a cosmic fireworks show, marking the death of a star and the rebirth of the black hole's hunger. Normally, these events fade after a few months. But the new discoveries go far beyond anything scientists have seen before. The discovery of 3 extreme events in a study combining data from NASA, ESA, and observatories around the world. Astronomers identified 3 black holes that completely shredded stars much larger than our Sun, between 3 and 10 times its mass. Each event released energy equal to 100 supernovae. Each lasted for months, glowing brightly before slowly fading. The researchers gave these rare events a new name: extreme nuclear transients, because they occur in the nuclear, or central, regions of galaxies and are far more extreme than typical star disruptions. These events act as cosmic flashlights, briefly illuminating supermassive black holes that would otherwise remain invisible. As lead researcher Jason Hinkle from the University of Hawaii explained, "These events are the only way we can shine a spotlight on black holes that would otherwise be completely silent." How astronomers found them. The first of these events, nicknamed Barbie, was discovered in 2020 by the Zwicky Transit Facility at Caltech's Palomar Observatory in California. Its official catalog name was ZTF-20 Auberby, but Barbie was easier to remember. It appeared as a sudden, bright flare from a distant galaxy, a glow that grew stronger over weeks before fading away. At first, astronomers didn't know what they were seeing. Was it a massive supernova? A strange gamma-ray burst? But when they compared it with data from other telescopes, including NASA's Neil Gehrels Swift Observatory, the pattern became clear. This was no explosion of a dying star. It was the signature of a black hole devouring one. Swift's instruments recorded the light in X-ray, ultraviolet, and optical wavelengths, and the way it brightened and faded was like a fingerprint, identical to what theory predicted for a black hole feeding frenzy. Two more events were later detected by ESA's Gaia Space Observatory in 2016 and 2018. Together, these three examples became the clearest evidence yet of a brand new category of cosmic phenomena. Why these events matter? These discoveries are more than just beautiful explosions. They're windows into the hidden lives of black holes, especially the biggest ones in the universe. Most supermassive black holes don't emit light because they're not actively consuming matter. They're invisible against the darkness of space. But when a star gets too close, it triggers a transformation. The black hole becomes an engine of energy, radiating across the spectrum. By studying how the light from these events changes over time, scientists can measure the mass of the black hole, the speed of the falling gas, and even the structure of space-time near the event horizon. It's like reading the black hole's heartbeat. A symphony of light. Each of these star-shredding events unfolds over months. The high-energy light from the initial destruction can take more than 100 days to reach its peak brightness, then slowly fades over another 150 days. As the light interacts with the surrounding dust and gas, it produces lower-energy emissions that ground-based telescopes can detect for even longer. NASA's WISE spacecraft, later renamed NEOWISE, helped map this process. By observing in infrared light, it revealed how dust around the black hole absorbed and re-emitted energy, allowing astronomers to reconstruct the environment around the event. This combination of space-based and ground-based data gave scientists their most detailed picture yet of how black holes feed. The bigger picture, as study co-author Anna Payne from the Space Telescope Science Institute put it, we're pushing the upper bounds of what we understand to be the most energetic environments of the universe. These extreme nuclear transients show that supermassive black holes can unleash forces capable of reshaping entire galaxies. When a black hole feeds, it doesn't just consume, it also blasts radiation and particles outward at nearly the speed of light. This energy can heat up gas, trigger new star formation, or even blow material out of the galaxy entirely. So every time a black hole eats, it changes its cosmic neighborhood. Fueling the future of discovery, this research was made possible through NASA's Finest program, a grant supporting young scientists. It gave Jason Hinkle, the lead author, the chance to chase these mysterious events and decode what they really were. Now, as a postdoctoral fellow at the University of Illinois Urbana-Champaign through NASA's Hubble Fellowship Program, Hinkle continues to explore how black holes grow over cosmic time. One of the biggest questions in astronomy, he says, is how black holes grow throughout the universe. And these new discoveries are helping answer it. Connecting the past and future, the results also connect to recent observations from NASA's James Webb Space Telescope, which is peering deep into the early universe. Webb has shown that black holes were already feeding and growing when the universe was only a few 100 million years old. But here's the mystery: only about 10% of those early black holes appear to be actively eating. What about the other 90%? They may be dormant, waiting quietly until a massive star wanders too close. And when it does, it could trigger an extreme nuclear transient like the ones we're seeing now. These events could be the key to finding the hidden majority of black holes that we can't otherwise see. Looking back in time, events like these are so powerful that they could be visible even from the early universe, more than 12 billion years ago. But because the universe is expanding, their ultraviolet light gets stretched into the infrared, the perfect range for NASA's upcoming Nancy Grace Roman Space Telescope. Roman, set to launch by 2027, will have an incredibly wide field of view and extreme infrared sensitivity. It will be able to spot these rare explosions from when the universe was just a tenth of its current age. With Roman, astronomers will be able to study how often these events occurred long ago, and how they shaped the evolution of galaxies and black holes over billions of years. The cosmic blueprint. Every discovery brings us closer to understanding the life cycle of black holes, from their birth in the early universe to their quiet existence